Welcome to Embedded. I am Alicia White, alongside Christopher White. Our guest this week is Thea Flowers. I think we'll be talking about synthesizers, making your first dollars as a small business, or mental health, or maybe all three. We'll see.
Hey, Thea. Thanks for joining us.
Hi. It's lovely to be here.
Could you tell us about yourself as if we met at a technical conference?
Oh, God. At a technical conference. Well, in that situation, I'm probably going to be like, hi, I'm Thea Flowers. I work in developer relations. I can help you make things. But if you met me on the street or something, I'd be like, I'm Thea Flowers. I am a swirling vortex of chaos that sometimes makes synthesizers. So
I like chaos, especially when I'm causing it.
Exactly.
Okay, so lightning round. Are you ready?
I'm ready. Let's do it.
Favorite chord?
Favorite chord?
Yeah.
Like in music?
Yeah.
F minor.
Favorite programming keyword?
Favorite programming keyword? Let.
I agree. Favorite fictional robot?
I like really sassy robots. So Weibo from Flubber, if y'all remember that movie, it's ridiculous. That robot's very sassy. So Weibo, definitely.
Favorite instrument of all time?
Ooh. Oh, that's like the hardest one. Why would you do that?
How about a favorite instrument?
I mean, I've played guitar most of my life, so I think that's probably my favorite instrument.
When I asked this question to somebody else, I didn't get a very satisfactory answer, so I'm going to try again. Worst 80s synth tune, or, if you don't like that, worst 80s synth sound?
The worst 80s synth sound, in my opinion, is like the really cheap, like brass patch that's on the otherwise incredible DX7. There's like one patch that's like supposed to sound like horns, but it just sounds like crap. And every time I hear it, I'm just like, oh no.
I know exactly what that sounds like. I'm hearing it in my head now. Thank you.
You should insert it into this part.
I might.
Hardware or software?
Hardware, I guess. That's so hard because like I've done software my entire life. I only recently got into hardware. So hardware, though, it's way more fun.
Do you like to complete one project or start a dozen?
Complete one. Like starting projects is easy, but completing one is like so hard, especially as someone with ADHD. So like when you finish one, it's just like, serotonin. That's amazing.
Do you have a tip everyone should know?
Like for life in general or like for hardware?
Your choice.
I mean, for life in general, it's like you can never have too many socks. For like, you know, tech stuff, it's you know, find a community, find people that do stuff like you do and learn from them. It's the best thing that you can do.
All right. So you make synthesizers, which wasn't in your much in your introduction. But I mean, swirling chaos part, but that's, and not all synthesizers are swirling chaos.
But the best ones are.
But tell me about the synthesizers you make.
Yeah. So I started I guess a business. I don't know, something that looks like a business, something that's legally a business. Last March, selling synthesizer modules that I designed. So these synthesizer modules are for what's called Eurorack. It's a very popular sort of synthesizer format where instead of like you buying like some off-the-shelf synthesizer that, you know, you plug in and it makes noise, you buy individual modules and you connect those together with patch cables. And sometimes it makes something resembling music, and it's a lot of fun, and it's really wild. So I make modules that go into Eurorack synthesizers.
We talked to Leonardo a few weeks ago about Eurorack synthesizers, and
awesome.
He mentioned VCV Rack, a simulator. Do you work with that too?
I it's on my list of things to check out that I never get around to. It's really cool. I mean, I've seen it. I've seen people use it. My customers use it. It's a great way for to try out modular synthesizers without like spending a couple $1,000s investing in building one. And it also I know that John Park in particular likes VCV Rack, and he uses both an actual hardware modular synthesizer and VCV Rack at the same time, which is super cool because there's ways to get the stuff in and out of VCV Rack, which is cool.
I have yet to really get into Eurorack at all. I have no Eurorack stuff, but I love synthesizers. What do you think draws people to modular versus non-modular or semi-modular?
I think, I can't speak for the whole, weird niche or whatever, but I think one of the things that really appeals to people is this idea of it being a non-traditional sort of instrument, right? Like with Eurorack, you're not playing notes. You're not trying to reproduce a melody in your head, right? That's usually not what you're trying to do. You're trying to take all of these various signals and kind of evolving processes and combine them together to kind of make something rhythmic, something that sounds like music, but isn't necessarily directly controlled by a human. And that's why you see a lot of modular setups that don't have a keyboard. That's for a lot of people, that's not the point, right? You're not there to put in notes and let it reproduce a note for you. For a lot of people, it's throw in this random source, quantize it, sample and hold it until it makes something that resembles a melody that you have no direct control over, but you have indirect control over. And I think that's kind of really interesting.
Is it the generative aspect? The not only putting in the beginning, but seeing how things build? I mean, I'm used to visual generative art. Is this?
Yeah, I think that's a good way of putting it. This is the equivalent in music of generative art. And I think that's a good way of putting it.
I've always been deeply confused about your modular, and I think you've just solved that confusion because I've never understood why people don't have keyboards and why a lot of times this isn't what I think of as necessarily musical in a traditional sense, even though when I listen to stuff people do with modular, I'm like, that's really cool. And it never really clicked for me. Oh, this is meant to be more chaotic, more generative, more emerging from these connections rather than something that you're intentionally doing.
Yeah, and I'll also admit that I'm a complete hypocrite. I do not use many generative stuff in my usage of modular. I mostly use it as a reconfigurable synthesizer that's, closer to what you'd get from a monolithic synthesizer. And yeah, so I'm the weirdo that's using modular for normal synthesizer stuff versus generative art. But that's what's cool about modular. It's flexible enough to accommodate a lot of use cases, and you can really build the instrument that you need for whatever you're trying to do.
Castor and Pollux, those are twins in Greek mythology.
Stars too.
Yes.
And they're stars.
But what was the mythology? Do you remember the story?
I don't.
Oh my God. I researched this when I was picking names for the module, and I've totally forgotten. I think
tell me it was going to be homework.
God. Yeah, right? Come on. I've forgotten. I just picked it because it sounds cool. Also, it's the stars that are in Gemini, and I, other than Big Honking Button, all of my modules have sort of space-inspired names and stuff. Even my future ones have space-inspired names. So
okay, so you don't need to know the history, the mythology. It was all about the space aspect. Okay, that's fair.
Right. Yeah, I mean, I have a Greek name, but I don't know much about Greek mythology. But yeah, it wasn't. I didn't name it after the mythological aspect of it. It was after the stars, which are in turn named after the myth. But
we don't care about that. That's fine.
Right. The meaning is lost now.
Okay, so there's a synthesizer named after stars. What is it? What does it do? I read about it, a modern reimagining of the voice found in the classic Roland Juno 106, which I assume for your customers means something, but could you tell what it does for me?
Absolutely. So, I mentioned that like with modular synthesizers, you kind of have this option of like building your own, like whatever instrument you want. And you have things like sound sources, like oscillators and samplers and things like that make noise. And then you have like things like filters that like change the way that it sounds. And like you have effects that can add things like reverb and delay. So Castor and Pollux is a sound source. So it is what produces that initial sound that gets further processed by the rest of the synthesizer. And it came from me wanting to have a modern Juno voice. And the Roland Juno is like, for those of you who don't know what it is, which might be a lot of you if you're not just like deep in the synth community, you've absolutely heard it. There's no way that you've listened to music at any point in your life and not heard it. Like it's unavoidable. It's like the DX7, which is like, the synthesizer you hear in a lot of Michael Jackson's tracks and stuff like that. The Juno is a synthesizer like that it's just so popular that it's everywhere. Like Sweet Dreams by the Eurythmics is like one that I always point at people, like that intro, that whole just synth sound in that song is the Juno all the way. Time After Time by Cyndi Lauper, that's the Juno. Like Take On Me by, Aha, that's the Juno. Like it's literally everywhere. And not just like in the 80s, it's everywhere in modern music too. Like if you're a fan of Churches, a lot of their songs use a lot of Juno sounds. Some of Haim's songs actually use the Juno sound, and like it's literally everywhere. And like this synthesizer was so popular because it was like the first like polyphonic synthesizer you could take on stage and it would be in tune. Because at the time, all of the synthesizers that were polyphonic were basically analog, right? This is before like, microcontrollers could generate, sound all on their own. And so with all this analog circuitry, the thing would just get out of tune so fast. And then, you would go on stage, you would warm up and you would get it in tune. And by the time you're halfway through your set, your synthesizer had warmed up a little bit more and it was out of tune again. And the Juno didn't have that issue. So it was really popular just because of that. But it was also popular because it sounded amazing. So Castor and Pollux is taking that inspiration, taking the central voice from the Juno and bringing it to Eurorack.
How do you go about designing such a synth? I mean, I assume it's digital and you do have a microcontroller.
Well,
it's not quite digital. It's a hybrid. And that's actually what the Juno was back in the day. It was a hybrid as well. It had a very, compared to compared to modern microcontrollers, it had a very, very simple microcontroller in it. But the microcontroller isn't generating the sound the way that we think about computers making sounds these days, right? It's not, generating samples and pushing it through an audio interface. It's controlling analog circuitry that creates the sounds. So you still have this sort of analog core, but you have a microcontroller that determines what pitch the core runs at and a couple of other parameters. And so that's the same thing that Castor and Pollux does. There is, a comparatively very powerful microcontroller in Castor and Pollux that probably could make its own music if it wanted to. But that microcontroller is mostly just serving to read some analog inputs and use those analog inputs, such as like the analog inputs like pitch, for example, and use those to digitally control an analog oscillator, or in this case, 2 analog oscillators. So yeah, it's this hybrid approach, which is really neat.
But you write so much about microcontrollers. I was like, okay, so it must be microcontroller based. I know she writes about microcontrollers a lot. I bet there is the SAMD21 in there.
Not that module.
Yeah, it is. It is the SAMD21 in there.
Oh, okay.
Yeah, but it's not the star of the show. It's just there to support the analog circuitry. And I actually wrote probably one of my favorite blog posts I've ever written in my entire life about the design of the oscillator that's in the Juno and Castor and Pollux. It has interactive like illustrations of what each part of the circuit does, and it has calculators built into it so you can understand why they picked the component values they picked. It's really great, and it's kind of like this result of like 2 years of research into how the Juno works. And so yeah, like that blog post is all about the analog side of things, which was a lot. And it was really challenging for me because I don't have a background in electrical engineering or analog circuit design. And so learning those things and wrapping my head around them were really, really hard for me. And the digital side of things is comes a lot more naturally to me. So that was quite a challenge.
That was a really great post. I'm still absorbing it, and I want to go back to it a few times because there was a lot of stuff I didn't understand about how oscillators work. And like, for example, everything starts as a square wave, and then it does it, it modifies that to make ramps and things. I was like, oh, that makes a hell of a lot of sense. That never occurred to me that that's how they did it.
Yeah, it's a neat strategy. One of the things I really love about like the Juno doesn't quite have this as much as Castor and Pollux does, but like you said, it starts as a square wave and then it gets turned into other wave shapes, right? And those have different timbres. But one of the waves it gets turned into is just a sub oscillator where it takes that square wave and halves the frequency. But the way it does it is with this little piece of digital / analog logic circuitry, right, called a flip-flop. And the flip-flop that I chose for Castor and Pollux has this really great sound to it, which is a weird thing to say about a piece of digital circuitry, right? It's like saying this RAM has great sound, but like the analog characteristics of this particular digital part leads to the sub-oscillator in Castor and Pollux sounding a lot like the square wave that you'd hear in the Game Boy. So if you're doing anything that's like chiptune inspired, like Castor and Pollux's sub-oscillator sounds so good for that because it sounds so much like the Game Boy's square wave, which I think is really cool.
They're square waves. They should all be the same. There shouldn't be a Game Boy square wave.
They got harmonics and junk on them, and you know how this works. We've had this discussion.
Yeah, there's something complicated called like the Shannon-Nyquist sampling theorem that I should know, considering I make synthesizers and deal with audio all the time. But basically, like there's no way that you can make a perfect square wave.
No.
So no matter what you do, like the circuitry involved in making a square wave is going to impart some sort of change in the way that it sounds. And, if you produce it one way, it sounds, very harsh and sort of hollow. But if you produce it another way, it can sound like a little bit softer and a little bit fuller. And I think that's really interesting. It's like, it's the same fundamental square wave, but depending on how you make it and how you push it out, it's going to sound a little bit different, which I think is really cool.
So I mentioned the SAMD21 because you've written about the clocks and you have a thoroughly commented linker script and the ADCs. Why that chip?
I think it's equal parts just like luck and equal parts like admiration. The SAMD21 is the chip that's in the Arduino Zero, and it's also the chip that you'll see in a lot of Adafruit's M0 boards. So like the Feather M0, the Itsy Bitsy M0, all of those. And it's a 48 megahertz 32-bit ARM chip. So like if you've played with like the original Arduinos that are these, 8-bit AVR microcontrollers, like having a 32-bit ARM microcontroller is a huge step up. So it's one of these chips where it's like, it's powerful enough to do, so many things, but at the same time, it's not so overly complicated that you need a PhD to get started on it, right? And there's so many resources out there already just because it's used in the Arduino and it's used in, the Adafruit boards. But not all of that information is like all that accessible to people who are just getting started with electronics. So that's why I write a lot about it. Other than the fact that I use it for, the stuff that I make. I think it's a really approachable chip, and I think it's a really powerful chip as well. So I just think there needs to be more accessible resources for it. So I think it's great to kind of write about it and talk about some of the like hidden secrets and stuff that Arduino hides from you that you might be able to unlock with the SAMD21. So
that's an M0?
Yeah,
okay.
It's an M0.
Yeah. Yeah, it's an M0 plus actually. But yeah, it's great.
It's power for performance is incredible. It is very low power for how much you can get out of it.
Okay.
Do you use that part of it at all?
I don't generally make anything that's battery powered, so no, not really. People have asked me to write an article about using low power modes for the SAMD21. So I've done a lot of research into that. And it's ridiculous. Like you can set an alarm and then put the whole thing to sleep and it'll draw like almost no current. I think I can't say too much, but I got approached by someone to design something that was battery powered that used the SAMD21 that would need to sort of sleep for a long time and wake up periodically. And I didn't end up doing the project, but I did the research and I was like, oh, wow. Like, even if I just power this from like a couple of coin cells, like it will last a long time. Yeah. It's incredible.
It really is. As far as chips go, the reason I would look at it would be somebody would say, I need it to be super low powered. I'm like, okay, let's go look at this line of chips. So it's funny to come at it from the other perspective that it's a popular maker chip and its competitor with the Arduino Uno, it's just so different. It's like going from standing in, oh, that's not a good metaphor. Going from standing in a closet, that was what I was thinking the whole time, to like being in a big living room. You actually can do all the stuff and move around and get so much more done. So
Yeah, but it's not as overwhelming as some of the newer chips where it's like going from standing in a closet and moving around to suddenly you're in a stadium and you're oh God.
The big ST chips are at this point indistinguishable from the A series sometimes.
Yeah. Like, and I have no interest in doing anything with an A series chip. And I'm sure your audience is familiar with the distinction, but for those who might not be familiar with it, like the M chips are designed for embedded use, whereas the A chips are what are called application chips. So they're like the things that run Linux and run, cell phones and things like that. Much more powerful, complicated machines.
Almost a computer. Almost.
Yeah.
Okay, so how do you go about designing a synth? Do you have a problem and you want to solve it? Do you have an idea, goofing off with electronics? What's the methodology?
I already described my methodology, which is that I'm a swarming vortex of chaos. But more realistically, the answer to those is yes, like all of the above, right? Soul, which is the first one that I designed, I made because I had a problem that I wanted to solve. I wanted to be able to control my modular gear from my computer. And while there's modules out there that do USB to MIDI and stuff like that, I wanted one that I could program and I could just kind of repurpose on the fly to do different things. Because for one thing that I'm using the synthesizer for, I may want, just pitch and gauge. Just say, okay, translate the note that I'm playing on my computer into a note for the synthesizer. But for other patches, I might want to be able to, generate like 3 random voltages in addition to that, or I might want to switch it up and use it for something else. And having that flexibility to just edit a file and change what it does was really why I put it together and designed it. For Big Honking Button,
which you may hate this, but that is my favorite thing.
Everyone loves it, and it's such a funny story to me because it was such a random idea. Like I was just like exploring like what the SAMD21 could do in terms of like playing back samples, and like I just played Untitled Goose Game, so of course I put a goose sample on there, and I'm sitting there playing with this, and my sister's like, "What are you doing?" I'm like, I think I have an idea for a module. And yeah, the rest is kind of history. Like I designed it between the time where I sent off Soul for production and when it arrived. So like I ended up launching both of those modules at the same time when I opened my company. But Soul was actually already in production before I even started designing Big Honking Button. And so it was just like this last minute afterthought, basically. Like I had planned to launch with just Soul, but I'm so glad I had the inspiration for Big Honking Button. And then for Castor and Pollux, it's actually something I've wanted to build since I started getting interested in synthesizers. I love the Juno. It's my favorite synthesizer, and I've wanted to recreate parts of it since I started this journey. So
for actually for all of them, I believe, but I know for Honking Button and for Soul, you mentioned about a file, you can change things, but this isn't recompiling. This is with CircuitPython, right?
Yeah, this is CircuitPython, and oh my god, it's such an incredible experience. When I would like first started with Soul and like wanted to see if it was even going to be something that people would be interested in, I ended up reaching out to a couple of people to like beta test it. So I ended up with 4 people that were beta testers, and one of them actually like live streamed her first interaction with it, and she'd never done anything with CircuitPython before, never even heard of it, I don't think. But like within like 10 minutes of her stream, like she goes, I wonder how I'll change this. And she opens up the file and she's like, oh, this is cool. And then she saves it and she sees the module reboot and just immediately start running her new code. And she's like, oh, I love this. And like just seeing like someone's face light up when they realize like how lovely the experience is, especially like us, like jaded software people who are used to like wading through all kinds of nonsense just to get something running. Like seeing that instant feedback and ease of use for something like that is really incredible.
But your whole system isn't written in CircuitPython, is it?
It depends. So for Soul, everything is written in CircuitPython. CircuitPython itself, is written in C and stuff like that. But for Soul, the driver for the DAC is written in CircuitPython. The code that parses MIDI messages is written in Python, and yeah, basically the user code is written in Python. So it all runs on CircuitPython, which is cool. Big Honking Button is also mostly CircuitPython. Big Honking Button's firmware in CircuitPython is about 100 lines of code. The only thing that I did special for Big Honking Button is I added an extra module to CircuitPython in C that lets it read the ADC with more accuracy. And that's it. It's actually entirely optional. The first version of Big Honking Button's firmware did not have that. So
why are you spending time looking at linker files if most of your code's in CircuitPython?
I have this problem where my brain does not do what I want it to do. It does whatever it wants to do, and I'm mostly just along for the ride. So, sometimes, I wake up in the morning and my brain says, you know what we're going to do today? we're going to research linker scripts for 5 straight hours. And you know what? I just got to strap in and go along for the ride. And yeah, I mean, so the reason why I even got down to that level is because Castor and Pollux's firmware is not written in CircuitPython. It is written in C. It is a bare metal ARM project. I am not even using microchips or Atmel's HAL libraries. It's just me, GCC, and CMSys headers. And I wanted to do that not because I'm a masochist, but just because I really wanted to get more familiar with the hardware. Like you mentioned, I've written blog posts about the SAMD21's like clocks and ADCs and timer peripherals and stuff like that. And that research came because of Castor and Pollux, because I was writing the firmware in this low level sort of way. And, I totally could have gotten away with writing it in the Arduino framework, right? Like I totally could have. But I did want the ability to sort of take the most advantage of the ADC as I could, because Castor and Pollux has eight ADC inputs that it needs to sample. And it needs to do that in real time because it is a synthesizer. It is music, right? It needs to do that faster than you can perceive it. And I wanted to take the most advantage of that I could. And that meant doing things like interrupts and messing around with the timers and stuff, things that the Arduino framework doesn't really love for you to do. But yeah, so I dug down to that level. And as I started sort of messing around with this bare metal ARM project, like, I had the linker script that I got from, Microchip, and it was just filled with all these things I didn't understand. Like, I could understand the C side of things, right? I can look at the CMSys headers and say, yeah, that alias points to some location in memory, and I can go look at the data sheet and I can see what that location in memory, controls. But you look at this linker script and you're like, where does this come from? Like, did someone drive by on a spaceship and just throw a flash drive out the window, and in that flash drive was this linker script? Because there's so many things in here that are named something and you don't know why they're named that way. And it's not arbitrary, because if you change it, something breaks and you're like, where does this even come from? So it was this one part of my project that I just completely did not understand and had no way of understanding. So I was like, all right, let's research this. Let's see what it is. And now I don't have to wonder anymore.
What is your background? Software?
Yeah, I've been a software engineer for professional software engineer for the last 12 years. And I've been programming for most of my life at this point, I think.
How did you decide to play with hardware?
I've always been kind of drawn to hardware. When I was in high school, I helped start a robotics team, which was really fun. And I was the one that ended up doing all the programming for the robot, which was great because I got to go test out code that made a big machine move around, which was really fun until you run over some kid's foot. It's yeah. So I don't know. That was interesting. And then my career in software kind of took me away from that for a long time. There was a long time where I just I didn't do anything with hardware. And also just because it was hard, right? Arduino hasn't been around forever. But eventually, I sort of gravitated back to it. I wanted to make, I think what actually got me back into hardware was keyboards. I wanted to make a mechanical keyboard and stuff like this. So that ended up dragging me a little bit closer to the hardware community. And I just fell into it like it was a black hole or something. The keyboard stuff was the event horizon, and here I am. So yeah.
And was it Arduino that was providing some of that gravity, or did you not need that? It was just kind of a nice path.
I needed every bit of help I could get, right? I'm not some genius that doesn't need to go through the basics first, right? Because my first experience with customizing code on hardware, post, robotics stuff in high school was changing the key map on my keyboard. And I was like, okay, this is written in C. I know C. I'm familiar with that. Like the whole process of like flashing the firmware back on there was like really weird. And I was like, I've never done anything like this before. Strange. And then I picked up an Arduino to kind of just mess around with. And I was like, this is kind of cool. It seems to be doing a lot of things for me underneath the covers, but this is really cool. And then I wanted to build something that made music. So I ended up using the Teensy and the Arduino there to build a little bit of a synthesizer, which was really, really cool. It was really interesting and really, honestly, like the hardware parts were easy. The software parts on that particular synthesizer were not as easy, but it wasn't because of it being run on hardware. It was just tricky things to write in general. And from there I just kept digging, right? I'm like, okay, Arduino's cool, but like what's happening underneath here? And then, this microchip provided, HAL start or whatever, or ASF4 is interesting, but what's happening underneath the covers? And here I am, suddenly an expert on the SAMD21, and I don't know how I got here.
And you have a business, which starting a business in March of 2020
is the dumbest thing that you could possibly do.
I wasn't going to frame it in those terms, but you said it, so I'm going to agree.
It's bold.
It's bold.
Yeah, it's a bold strategy. Let's see how it works out. Yeah, it was an absolutely silly thing to do. But it was always sort of like I did it with the intent of it like not going anywhere.
Because you were working a full-time job at the time.
I mean, I still am. Okay. Yeah, I still am full-time employed. But yeah, I was working a full-time job and I was like, okay, like people might be interested in buying this thing. I set aside a budget at the beginning of the year for me to kind of do this because like all of it was like learning. I wanted to learn things. I was like, okay, I've learned how to like make my own electronics, but like how do electronics get made? So I was like, okay, what would it take to manufacture a small run of synthesizer modules? And I looked into that and I'm like, I could do this. And so, yeah, like, kind of the first little batch of modules with Soul and Big Honking Button were a learning experience for me. It was just learning how the hardware industry actually makes physical products. And so like, I kind of started it with this idea of like, it may not ever go anywhere and that's okay. And I didn't need to like push it to be anything more than that. Right. I didn't have to like bet the farm on it and like stress about whether or not I'm going to have enough sales, which is why I started it in March of 2020 because it's just kind of like, if people buy it, that's cool. If people don't, that's cool too, because I learned something, right? And yeah, almost a year later, it's been surprising, I think, to see how far it's gone.
I mean, not quite even a year later. And you tweeted not too long ago that you actually had profit.
Yeah. Which was a surprise to me, despite, being the one that does the bookkeeping because I'm the only employee. It's just, yeah, I was like, wow, huh? Because like I said, I set it aside an original, like a budget for it to start with. And at some point I was like, oh, the budget's back. Like I made it all back. That's wild. I didn't expect that to happen. But, at the same time, I did do math as I, planned out the production for each of these modules to like make sure that like they made a little bit of money, right? Like not that like I was, making myself poorer by making the modules, that, there was at least some net positive there. So, yeah. So it shouldn't come as too much of a surprise if I, paid attention to the math, but emotionally,
yeah,
it's a surprise.
How did you market and sell and package and ship and kit and build all of this?
Wow,
the question went on longer than I expected.
How much time do we have? So fun fact, I've done almost no marketing. And I joked earlier that I'm the only employee, but I'm actually not. I brought on a friend of mine, Maggie, when I moved here to Atlanta to help with shipping and fulfilling and, just kind of making things keep moving. Because, as I mentioned earlier, I struggle with ADHD. I also struggle a lot with depression and anxiety, which makes it really hard for me to consistently ship out products, as you can probably imagine. So having someone I pay to help with that is really great. But in terms of marketing, I haven't done any. And I remember Maggie asking me about it. And I'm like, I don't really do anything. So most of Winterbloom's marketing has just been word of mouth. And it's been, there's been like 2 particular communities that have been really, really wonderful for me in terms of Winterbloom. Like the Adafruit community, there are, quite a few people in there who also do modular stuff. So when they saw a CircuitPython powered modular synthesizer kit, they were like, oh, I'm so on top of this. They were super excited about it. And I'm very thankful for that. I'm also part of a Discord that is people who are transgender and involved in the synth community. And, they got to kind of watch a lot of the process of me designing these modules. And then when I released them, they were my first customers. And I'm so thankful for that. They're my friends and my customers. And it's great to be in that situation. So yeah, from there, it's just word of mouth. I post things on Twitter, people retweet them, and I get sales sometimes. But yeah, I've actually done a little bit more active marketing with Castor and Pollux, where I've actually sent modules to people who, have significant followings, like Jeremy from Red Means Recording, who's a super awesome person and a nice dude in general. I had sent him over a Castor and Pollux, and there's a couple of videos you can see of his where he's using Castor and Pollux, which is really, really cool. There's a few other people who have them in hand as well, but they haven't quite posted about them yet, which is totally fine. There's no deadline. So yeah, that's marketing. Marketing is basically nothing. I need to step it up. In fact, I just need to pay Maggie to start doing marketing. And in terms of like building and shipping and packing and all this stuff, I use a contract manufacturer to do all the surface mount stuff. So that gets done ahead of time for me, which is great. When I get them, I program them, I test them, and then I do any through-hole assembly and package them up. And for some modules, that's really easy. Big Honking Button is so easy. It's actually, if you want to get into modular and you want to do kits, get a Big Honking Button kit. It is one of the easiest electronics kits in the world. And when you get done with it, you have a button that honks. So, I really can't sell it any better than that. But Big Honking Button's not too hard to put together, so it's not too bad. But Soul, oh my God. The sort of retrospective on Soul's sort of manufacturing difficulties is like, oh God, I'm already working on a new revision of it so that I don't have to do the same manufacturing steps that I have to do now. And that's the most important thing. I want to add new features and I want to make it, a little bit better. But for me, it's that Soul is hard to put together. And, if I'm going to sell more, I need to do better at streamlining that experience for myself.
I was going to ask you what your biggest surprise was going through this process, things you hadn't realized, but
yeah, mostly just it's scale. Scale changes everything, right? That's true in web dev and it's true in hardware. Selling 50 souls is, not too bad, but when you have to put together a bunch of them all the time, you're like, okay, I should have designed this differently. And I avoid saying I should have designed this better because I didn't know any better at the time. But now it's okay, if we're going to go back and revisit that, let's fix these things so that it's not so onerous to put together.
Now that I understand what design for manufacturing means.
Well, when you're the manufacturer, that's, it takes on a different meaning.
Yeah, absolutely. I also so what was surprising is hardware testing and programming is really interesting to me. I mean, I publish the factory setup scripts and everything with my modules. Like everything I do is open source. But like I ended up having to purchase a bench multimeter for Sol so I could calibrate the DACs. And like learning how to program a bench multimeter was so cool. I super enjoyed that. And I had to do a similar thing with Castor and Pollux and an oscilloscope. Castor and Pollux's setup script runs through and scripts an oscilloscope to take measurements and make adjustments, which is so cool. It's so cool to watch these like neat instruments like make measurements and like, you know, have your program like do all of that for you and, you know, like create better testing calibrations than you could ever do manually. And I think that's really, really cool.
You just mentioned that your design, your hardware, your software, your manufacturing scripts are open source. And I wanted to ask you, why aren't people just making them themselves? Are there people out there making them themselves?
I think there's a couple of people who I reached out to who have like asked me questions about making them themselves. And like, I encourage it. If you want to, you know, download the source files for Big Honking Button and, you know, go order the PCBs from Oshpark and order the components and put it together yourself, knock yourself out. Please do it. I super encourage that because like, that's how I learned. If other people did not make electronics kits and make open source hardware, I would never have made any of the things that I made. So it's so important to me that I kind of give back, right? So like I'm never upset if someone makes their own of things. Like right now you like Castor Pollux is for pre-order, but the hardware is open source and it's already published. So if you really, really want a Castor and Pollux, you can go make one yourself. You also need to have an oscilloscope so you can calibrate it, but you can go and make one yourself. And, you know, I think part of the reason why people don't just go and make it themselves is that most people appreciate the value of, you know, someone else putting something together for you.
Oh, yes. So appreciate that value. I really do.
And they also want to support my work. And, you know, like, like people will actually pay for things. It's, you know, like capitalism doesn't require you to hide, you know, all the details so that, you know, people have no choice but to buy things from you. It turns out if you give them a choice, they will sometimes buy things from you, which is really, really nice. So yeah. That and like, you know, it is, you know, like putting together hardware is not a skill that everyone has. And not everyone has the equipment to do it. You know, like, you know, all of my modules are surface mount stuff. And, you know, it's not like you buy a dev board and you buy you order, you know, a printed circuit board that you stick the dev board on and you add some jacks to it, right? Like I actually went through and like integrated the, you know, the microprocessor and everything into the design. So you have to deal with like soldering QFN parts or QFP parts and all of this stuff. And like, not everybody wants to mess with that. And I totally get that because I don't want to mess with that. I pay a contract manufacturer to do it. So, you know, I think that's part of it too. Like it does require a certain, you know, level of comfortability with that before you want to do something like that. And the other thing is like, one of the things I'm really planning with all of my future modules, including Castor and Pollux, is I want to offer kit versions of every single one of them. Because I mean, I mentioned my manufacturing process is the surface mount stuff gets done by somebody else, and then I get it and I do all the through-hole stuff. Well, that's a kit, right? So, you know, instead of me putting it together for you, I'll just package up all the components in a nice little kit and make a nice little guide for you, and you can put it together yourself. So people can still get that satisfaction of having put something together, but they don't have to deal with all of the fussy bits of like the surface mount components and testing and calibration and all of that stuff. I can do all of that ahead of time and just give you the joyful part of it.
I think it's funny that some companies do believe that in order for capitalism to work, everything has to be hidden.
Yeah, I've never bought into that. Like that's like, I don't know, maybe it's the socialist streak in me or something, but like, I'm just like, you don't have to do that. People will pay for stuff. Well,
and running one board and building it myself with the uncertainty of whether I did it wrong or whether there's a bug somewhere, it's so much worth paying you to just send me one.
Right, exactly.
And yet, if somebody has a SAMD21 board, which they're pretty easy to get and is willing to put in a little bit of time, they might be able to use your code and not have to pay as much, but get to try out having a modular synth piece, and you make it available to them in a way that encourages them to start building things.
Yeah, actually, don't tell anybody this, but you can run Big Honking Button's code unmodified on a Feather N0 Express. Like, plug in a speaker to the right pin and plug in a button to the right pin and put the code on there, and you have a Big Honking Button. Like, that's it.
Except you don't have the very satisfying button part.
Yeah, exactly.
And the button is really, I think that's important.
How long did you spend choosing that button?
Not long. I mean,
Okay.
I picked my favorite button of all time, which is an arcade button, right? It's a Sanwa arcade button. It's exactly what you would find on an arcade machine. I have one
in my parts kit somewhere.
Yeah. So I was like, that's obviously the button that needs to go there. So, yeah. I mean, it was actually really funny. As you speaking of the buttons, when I first launched Big Honking Button, out of like some, I guess, like artistic integrity or whatever, I was like, I'm just going to offer white panel, orange button. I want it to, that's the colors I picked out for it. That's what I'm going to sell it as, right? Like a real Henry Ford moment.
Looking at your website, that didn't last.
No, it did not. And here's why. So my first run of Big Honking Button was 150 units. And I'm doing part sourcing, and I reached out to my source for the buttons. And I was like, hey, can I order 150 orange buttons? And they came back with, sure, but we only have 58 in stock. And I was like, okay, give me those, but also give me some of your other colors. And that's why there's more colors for the Big Honking Button.
I mean, if it was in a rack, it would be nice to have it be multiple colors.
Yeah, absolutely.
The orange is very duck orange.
Yes, I love it. I love it so much. My favorite color combination, though, is black and pink. I think that looks really great.
Your boards are pretty, too. Do you spend a lot of extra time making them pretty?
I don't know. It's part of the process, right? Like, it's not a separate thing that I do. Like, I don't lay out an ugly board and then go back and put pretty things on it. I just go from the start. Like, yeah, I'm going to make this pretty. Although I will say, like, when I did the second version of Big Honking Button's boards, I did go through and like make it a little bit prettier, because like the first one I did was like no special graphics at all on it, right? And I didn't have a logo yet when I made it and all of this stuff. So when I went through and did the second revision, I made sure to put our branding on the back of it and put a nice open source hardware logo on the back of it and put the nice Creative Commons logos on the back of it, so that it's nice and pretty on the back. And I'm happy I did that. I also made sure that the designator for the jack said honk out, and I think that's great.
You write about your software, you write about learning with your software, and you provide that educational resource. Your board is open source, and it's intended to be looked at. It's not intended to be hidden away in a package. And you've been very upfront with your business information. I mean, even telling people I've made a profit is kind of an unusual thing to do.
Yeah, and our bill of materials is available too, so you can see exactly how much my profit ratio is on every product if you look closely enough.
How much is your goal to teach people things versus to make things?
It's a weird question, because like I don't see those as separate. Like that is my goal, right? Like my whole, like, I guess, I mean, this sounds corny, but like my mission in life is to empower people with software and hardware, right? Like technology is this thing that like is really transformative. And a lot of the ways that we see technology in the modern day is used in an exploitative way, right? Like It's used to, control resources. It's used to consolidate like means of communication and all of this stuff. And like, it's easy to forget that technology, when it's personal, is really, really empowering and transformative. And for me, like, that's what I want to do. That's the whole purpose of this, right? And so, it makes no sense for me to build a module and sell it if I don't also have a chance to tell people how it works and why it's cool and why it's interesting and, how you can take that information and use it to make your own stuff. And I think that's the most important part. Like, the fact that I have something to sell is secondary, honestly, to the education aspect of it. It's more about that than anything.
It's funny, you started that question with they're the same, but you ended it with the education part.
Well, yeah, I guess you said, like, how much is it my goal to make something versus teach something? Well, like, yeah, you have to make something to teach something. But in terms of selling something, that's just, that's just bonus. It's just something else. It's there,
One of the reasons to ask the question is because last week when we had Emily on the show, we talked about how sometimes you do things, you build things, people build things, she builds things because she wants to build it or wants to have it and doesn't want to have to explain it. And you've made a pretty big effort to make sure that everything you do is explainable. And that's, both paths are admirable. I'm just not always sure that everybody knows they're on one or the other.
Honestly, I wish I had the mind that Emily has so that I could create something that's unexplainable. I feel like that would be like my short circuit moment, right? Like, that would be the moment that like the moment I create something that can't be explained at all is the moment that the black hole inverts and the universe, goes backwards, right? Like, so yeah, and both are admirable. Like, I think that, like, there's parts of technology that are artistic and indirectly empowering by saying something, by having a message, by being unexplainable. And there's this aspect of technology that is practical and empowering. And I think, like, what makes humans humans is technology, right? Like, the fact that we learned how to, use tools and communicate, and, like, yeah, it permeates everything. And there's so many different ways of approaching it. And I really admire Emily's approach to it. And I appreciate our differences on that. And I think it's wonderful.
Okay, I have two more questions. One of them is dumb.
Awesome.
How do you make the panels? The PCBs I understand, but the Castor and Pollux, the panel is super cool and it's got all these little stars and multicolored and things. And so how do you source and manufacture those? What are those?
That is not a dumb question at all. So for Winterbloom, our panels are PCBs.
Oh, okay.
Yep. We use a PCB manufacturer to make the panels. And we do really high quality stuff too. We've been using PCBWay's advanced PCB service for that because we have like specific tolerances, and we we want to make sure the art comes out correct in the end. We've also we're going to use Royal circuits for one panel so we can get a specific color, because they'll do any color you want, but it's a little bit more expensive. But that's something I haven't announced yet. So, but yeah, so they're just PCBs, and for Castor and Pollux to get the whole like little light thing, it's actually just exposed FR4.
Okay.
So the substrate is just exposed. So on the back of the panel, there's like a cutout in the solder mask, so that you can just see straight through it to see the FR4. And then on the front, it's we basically have the star part of it cut out the both the copper and the solder mask, so that you can see the FR4 on both sides. And when you have that, it becomes an LED diffuser, which is really cool.
Yeah.
Yeah. And I've talked to other manufacturers about how they do their panels, and a lot of people do metal photo, like aluminum panels that have basically like screen printed or I can't remember exactly how metal photo works, but some kind of chemical process. It's something that really isn't practical until you're shipping like 1,000 of something.
Yeah, right.
And apparently it's really hard to get consistent. I think it was someone, maybe Noise Engineering, was telling me that like their manufacturer ended up bringing that in-house because like they were contracting it out and like they would just get so many that were just wrong. So they bought their own machine to do it so that it would be more consistent. And I'm like, oh God, I don't want to go there.
Yeah.
What color do you need? You don't have to tell us what it's for. I just need to know what color.
Pink.
All right.
Yeah.
I think when we talked to Lenore, and I think they mentioned that company in pink, didn't they? Lenore and Wendell.
I remember pink boards being not yet available.
Yeah.
Yeah, you can get them. You just got to pay a lot of money. So, I mean, it's not too much in the grand scheme of things. It's like, I think depending on the size and stuff like that, it's like $8 per board at 500 boards or something like that. But yeah, you need to order a lot of them to make it worthwhile. But yeah, pink. One of our panels is going to be pink, and it's going to be obnoxious, and I'm excited about it.
The other question I had going back to Castor and Pollux was, how much part level reverse engineering did you do? Did the voice kind of, do the chips that the Juno was made from still kind of exist, or did you recreate it with modern parts?
Oh God. So the 60 is made out of discrete components. So you can actually look at the service manual and see how it was put together, which thank God, because that's where I actually got the component values from for the blog posts and stuff like that. Castor and Pollux's component values are different just because it operates at different voltages and stuff.
Okay.
The Juno 106, on the other hand, it is like a custom integrated circuit. They call it the voice chip. And they're no longer produced. There's someone who's like thoroughly reverse engineered them and makes replacement voice chips. And I was going to get my hands on one of them, and I can't remember why I never did. But the service manual still like contains a schematic for that chip. It doesn't tell you the component values or anything, but it gives you a general idea of what's going on inside of the chip. It's basically like what you'd see in, a data sheet for like an op amp, right? You see the equivalent circuit. So it's like that. So you can at least draw some conclusions. And if you look at the blog post, I mentioned like how the 60 uses positive control voltage and the 106 uses negative control voltage. And the way that you can tell that is because if you look at the equivalent schematic in the Juno 106, you'll see they're using a different type of transistor. And that like says, oh, that's using, negative control voltage. So, there's a lot of, it documents enough so that you can figure it out just from the service manuals.
Cool.
Yeah, thankfully I didn't have to decap a chip or anything.
Yeah.
It's weird that they used to include schematics in the manuals. Can you imagine getting like a rice cooker now and having a schematic
Computers
in there?
used to. I mean, the Apple II Plus over there came with
the Apple II Plus
schematics.
So Maggie and I have talked about including like little manuals with our modules. And that's something we haven't done yet because, it requires like, getting a printer to do things and things like that. But if we do, I'm totally including a schematic with each and every one. It's going to happen. I will put in the time to make KiCad schematics look good so that I can put them in a manual.
Thea, it has been wonderful to talk to you, but I suspect we all need to go about our weekends. Do you have any thoughts you'd like to leave us with?
I think the biggest thought I want to leave y'all with is like every time I get asked, questions about how to get into hardware and stuff, the answer is always the same. Find a community. Find people who are doing things that you want to do with hardware, right? If you want to make keyboards, go hang out with the mechanical keyboard nerds. If you want to make robots, go hang out with the robotics nerds. If you want to make, all kinds of creative, interesting things, go hang out with the Adafruit folks. Like, there's a lot of friendly communities, and the best way for you to learn and get into something is to have a group of people that are interested in the same thing and that you can ask questions of and that you can share things with.
Our guest has been Thea Flowers. She's Stargirl on Twitter and general social media. Check out Winterbloom for her craft synthesizers. And of course, we'll have links to blog posts and her GitHub in the show notes.
Thanks, Thea.
Thanks, y'all. This was really great.
Thank you to Christopher for producing and co-hosting, and thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on embedded.fm. And now a quote to leave you with from Chico Xavier. Though nobody can go back and make a new beginning, anyone can start over and make a new ending.